All right, nerds, here we go. Scientific notation, follow along. This is going to be a video on how to use the Casio calculator. Okay, so I'm going to ask you guys to type things in as we go and write a few things on here just to practice using the calculator. Okay, while we're taking a test or homework or quiz, while we're taking a test or a quiz, you can't ask me how to use the calculator. So right now is your practice to make sure we get this down and make sure you know what you're doing. All right, so today we are starting scientific notation. Okay, we use this for very large and very small numbers. Scientific notation numbers are expressed as the product of a number between 1 and 10. Always between 1 and 10. And a whole number, power, which we call an exponent. Exponent indicates how many times a number must be multiplied by itself. Some examples are as follows. Okay, so on here we have 10 to the first is 10. 10 to the second is 10 times 10, which is 100. 10 to the third is 10 times 10 times 10, which is 1,000. Okay, let's practice another one. 10, and we're going to do exponent, which is this key here, the little triangle. Okay, 10, triangle, and let's say to the fifth, which is 10 times 10 times 10 times 10 times 10. And we get that, we should have 100,000.
Good morning, Boone faculty. The faculty meeting will start in the auditorium at 7:30. Again, the faculty meeting will start at 7:30 in the auditorium.
7:30 meeting. For another example, the number 45 looks like billion. Okay, 0,000,000,000,000,000,000,000,000. Let's type that in. 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 equals right there. Okay, our number is 4.5 times 10 to the positive 16th, and that's what we have right here as well. 4.5 times 10 to the 16th. Okay, the 16 tells you that there are 16 decimal places between the right side of the 4 and the end of the number. We're moving this decimal point 16 places to the right. Okay, let's do another example. So we have 2.641 times 10 to the 12th. Okay, so if we were to write this out, 2641, we want to move our decimal place 12 spots. 1, 2, 3, 4, 5, 6, 4, 5, 6, 7, 8, 9, 10, 11, 12. Decimal point. Okay, once again, it was here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We've moved our decimal point 12 places. And we always want to divide this up by by comma. So every 3 zeros, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, 2,641,000,000. All right, next, very small numbers are also written with negative exponents. Negative are small. And we will have lots of small numbers at points because we'll have things that we're going to weigh out. Okay, so if we want to write out 0.000000000000378, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 0 point, type it in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I think I did that right. 378. And we should have 3.78 times 10 to the negative 15th. That's our answer here. Okay, so if we were to write that out in scientific notation, that would be 3.78 times 10 to the negative 15th. Okay, let's do another example. If we have 7.45 times 10 to the negative 8th, okay, the negative 8 tells us that we are moving it 8 decimal places. Okay, So now the last one, we moved it to the right. This one will be moving to the left because it's a small number. If we moved it this way, we'd be making it larger. 7.4, 74, 745. We're starting here. We want to move it 8 places. Okay? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is 0.000000745. That's the same thing we have here. Okay, we just moved it 8 places. All right, in both very large and small numbers, the exponent tells you how many points the decimal point moved. Exponent tells us how many places the decimal points are between the right and left side of the first digit. If the exponent is positive, the decimal places are to the right of the number. If the exponent is negative, the decimal point is to the left of the number. So on this one, we moved our decimal point to the left. The following are some examples of numbers written in scientific notation. Okay, so let's take a look and see what we're looking at here. Okay, so 30 is not between 1 and 10, so that's why we're going to change it. Okay, so to change it, we move it 1 spot, and that's a positive number. If this is a large number, and by large, it's bigger than 10. And small means we're less than 1. Okay, 30 is bigger than 10, so we know our exponent is going to be positive. Okay, we move it 1 spot, 3 times 10 to the first. 150 is larger than 10. Okay, so our decimal points here, 1, 2. Okay, so it's 1.5 times 10 to the second, because this number is now falling between 1 and 10. Okay, over here, large number because we're bigger than 10. We start with our decimal point here, 1, 2, 3, 4. So our number would be 6.0367 times 10 to the fourth. Down here, we're less than 1. We're at 0.3. So if I move it 1 this way, now I'm 3 times 10 to the negative 1. Okay, anything that's a small number is negative. Over here, we're going to move it 1, 2 places. Okay, because 4.6 falls in between 1 and 10. And we moved it 2 places to the right, okay, making it negative 4.6 times 10 to the second. 2 times 10 to the negative 6. 1, 2, 3, 4, 5, 6. Moving our decimal point 6 places, 2 equals 2 times 10 to the fourth. I'm sorry, to the negative 6. All right, so now we're going to start some critical thinking questions. Okay, so on here, number 1, first thing, circle 2 of the following numbers that are incorrect. Okay, and you're going to start working with your partner on this.